morning to everyone who's seeing this. And today we are going to make a simple project. And my name is Muhammad Asrul bin Muhammad.
And my name is Krishna.
Okay, so what are we presenting today? What hero? Who are we gonna help? We are gonna help a environmental the health officer, which like ask them how the air quality is like. Need to ask one by one people. So with this project, we can make it easier for them, and they not need to go ask one by one. So they all can just straight see from the LEDs. Okay, so what are the SDG that are we going to use? So good health and well-being, which is SDG 3. Why? Because fighting pollution and related sickness, because it's help us and make us more healthier. And we can warn people before like they all kena sick, they know, they will be aware about their health. And the third one, it can help doctors and communities, because the data can assist doctors, schools and cities in improving air quality in anyone's health. Okay, so the problem statement is more air pollution in the city in Malaysia. Why? Because of the factories, the cars, the open burning, and this issue will make older people or kids sick or die earlier. Okay, so
our solution is a smart air quality monitor, and it helps us to detect the temperature and the type of the bad gas in the surrounding.
it tells whether it's good or poor, and it can make decision so that before we want to go out, we know how the air like the air quality outside is. Is it good or bad?
So the advantages are real-time monitoring. It can provide a feedback on air quality, and it's a very cost-effective because we are using only 3 components like the MQ135 sensor and 2 LEDs, green and red LEDs. So it's a very affordable price project. It's very portable as well, because this is a very easier and a small project. We can bring it to anywhere and we can use it in any places.
It's not just small, but it's very simple and also it's very useful. Okay, so these are the materials we used. MakerPi, MQ135 sensor, 35, took one LED, green LED and red LED, MakerPi, groove to groove, 2 groove to groove, and 1 groove to 4 pin. Okay, so this is the sketch idea. From the top view, this is the MQ135 sensor hole, and this is the LED for red or green, and this is the MakerPi. So this is the front view. MQ135, 2 LEDs, and MakerPi. That's it. And this is the flowchart. So when it read the gas, if the gas is more than the threshold voltage that is stated, then the red LED will be on. If not, if gas lesser than the threshold voltage, the 2, which is the green LED, will on, because it's good air. And that's it for okay, so the coding. So this is the pin which is we are going to make it at the MakerPi, and this is the MQ135 sensor pin, the air sensor, and this is the LED, green LED, and this is the LED for red, which is GP17 and GP5. And this is how you get the voltage. Okay, so this is the threshold voltage, 0.110. You must adjust this value based on your experiment or observations. And this one is the if get voltage sensor pin, meaning which from here sensor pin and got voltage here. So it's gonna do some mathematics and print the sensor value, which the MQ135 sensor, and in the voltage format. And if the voltage is more than threshold voltage which is stated just now like this, then the red LED will on because it's a bad air meaning. And if this one is less, then LED 3 if the voltage more than the threshold voltage, the green LED will on. Okay, so this is the time slip, which is what it's gonna look. Okay, so this is the MQ135 gas sensor, the wiring. So from the VCC to 3.3 volts MakerPi RP2040, and GND to GND, it's basically just the same. And AO, analog output, from the MQ135 to MakerPi RP2040, and DO, which is from the MQ135 to MakerPi RP2040. So for the LEDs, for the red LED VCC to 3.3, just plug in the groove inside. So because we're using groove LED, right? So just plug in the groove, then you put inside a groove, and must see the yellow wire and what is the GP, then you can put inside the code. Same for green LED as well. Okay, so this is the finishing product. This is also a 3D printed casing as well. We have put inside in the zip. Okay, so the impacts.
So the impacts are, you can have a real-time air quality feedback because this from our project we can easily see the type of the good air, bad air from the green LED and the red LED. If it's a good air, the red LED will indicate, and if it's a bad air, the red LED will indicate. So the educational value are from the project we can learn about the electronics and the programming, and it's a very cost-effective solution because we can use it for our personal users and
education and also factories, because factories use smoke. And for education, we can teach kids because it only takes us 3 days or 2 days to do. Okay, so first, what are the problems we have faced? We have faced coding. If we have coding problem, you guys can use ChatGPT or some tutorials from YouTube. And the 3D printing, we need to check the size, the quality, and also you need to use a good power source to activate the MakerPi. And what can we add if we had more time? We will add an LCD so that you can see just straight from here. You can display the output. Now it's already displaying with LEDs, and we will add in future, we will add LCD, and also develop an app because you can get alert and awareness. And we can also include wireless like connectivity, because now we are using wire. So in the future, if we had more time, we would actually make it wireless, like through Wi-Fi or Bluetooth. How can this system improve? How? By providing real-time air quality feedback, people can avoid exposure and harmful air condition and take preventive measures. Like they all can, from the air, you can be alert. So before we kena this one, they all will know from here. So as a conclusion, this project offers a practical, affordable solution and real-time air quality monitoring.
And for the project, we use MQ135 sensor because from MQ135 sensor, we can detect various types of gases such as ammonia, carbon dioxide, hydrogen dioxide, and many more harmful chemicals in the surrounding.
So it's simplicity and accessibility. That's why it's small and it's very simple. It's also very useful for us. And this is also very good to educational, personal, and also, as stated, a factory, because they use smoke in of the factories. So we can promote better health and also environmental awareness. So that's all from us. If you guys have any question, please pop up in the comments. Thank you. Bye.